Myself, Sunil Kumar Singh. I am graduated from PIT Sindri in 1994 and MTech from BHU in 2000. I am presently working as Head of Department of Mining Engineering, Bilaspur College of Polytechnic, Bilaspur. I have more than 20 years of teaching experience. Now, I am present here to deliver speech on mine explosion. Explosion that automatically takes place in underground mines. The contents are introduction, fire damp explosion, causes of fire damp explosion, quartz diagram, control of fire damp explosion, coal dust explosion, causes of coal dust explosion, control of coal dust explosion, stone dust barrier and references. Introduction. Explosion is a sudden combustion process of great intensity. It is accompanied by release of large quantity of heat energy and development of pressure. In explosion, the original gas, methane and solid substance coal is converted instantaneously into gaseous products. An explosion is also invariably accompanied by violence on a large scale. Basically, this is an automatic process. It happens without any prior information. It is just felt by experience and can not be detected, just like earthquake. An earthquake cannot be detected and cannot be predicted. That is why the explosion, whether any type, cannot be detected in mines. Mine explosion are generally regarded as serious and constant hazard in underground coal mines. In underground metal mines, there is no any incident of explosion due to so many reasons. In coal mines, explosions are caused by ignition of fire damp, that is called fire damp explosion. Fire damp means methane, mainly methane, by ignition of coal dust. This means coal dust explosion, by both mixed explosion. That is, first of all fire damp explosion takes place, then after coal dust explosion taken place. In metal mines, explosions are due to sulphide dust, but there is no any case in Indian mining industry, and we cannot any evidence of explosion that have taken place in underground metal mines. That is why we are mainly focusing on the explosion that have taken place in underground coal mines. Fire damp explosion. Fire damp refers to the natural gas mixture emanating from the strata of coal mines, that is emitted from the underground coal mines whenever we extract coal and expose more and more surfaces of wall rock. Such gas mixture consists chiefly of methane with small traces of other combustible gases like ethane and ethylene. These gases are also highly inflammable and are also called as hydrocarbon. Therefore, fire damp is often considered synonymous with methane. Methane burns in air when ignited with a pale blue flame, but when it is mixed with air, it can explode on ignition. That is why it is also taken as a good fuel, but if its concentration is in a explosive limit, it can mix with air in a confined place, not in an open place, but in a confined place. it can explode on ignition. The combustion or explosion takes place according to the equation CH4 plus twice bracket O2 plus 4N2 CO2 plus 2H2O plus 8N2. This is a chain reaction. It occurs continuously, and once started, then it propagates to a larger area. The optimum or stoichiometric mixture is formed at 9%, 9.5% methane. The methane, however, forms flammable mixture with air over a range of approximately 5 to 15%. This is called its explosive range, limit of explosibility. If the methane content of a methane air mixture is greater than 9.5%, the oxygen percent is not so much sufficient for its complete combustion, and if it is also less than 9.5%, oxygen or atmospheric pressure will be in excess. A pure fire damp explosion does not extend over a wide area unless there has been emission or accumulation of large quantity of methane. It means the concentration or accumulation or amount of methane in a particular area of underground coal mines should be sufficient, otherwise the explosion of fire damp cannot take place, because the reaction is chain reaction, or for chain reaction to be maintained, the quantity of fire damp should be sufficient and distributed for a longer area or longer distances in a place, in a roadway, near the roof. The various causes of fire damp explosion in mines may be grouped under the following headings. First of all, it is due to short firing. Basically, the presence of methane has a property that it cannot self-ignited or self-explode unless otherwise there is something, an external source. Shots not properly placed, causing an overcharged and blown out shots with detonator wrongly placed in cartridge, shots fixed without examination for fire damp. Such type of happenings is during blasting, particularly in gaseous seam, in which the emission of methane is up to 10 meter cube per ton of coal extracted, and any wrong practice of blasting can cause a sparking and which ignite or explode methane. Naked light. Naked light matches or other contrabands introduced in mine illegally, because the consumption of contrabands causes the burning of or igniting of match, and which cause burning and explosion of methane. Defective or damaged flame safety lamp. If flame safety lamp used in mines is damaged, if its glass is broken, then the flame becomes naked, and the naked flame is a prime source of ignition for methane and causes heat and finally causes explosion to the methane. A spark in electrical appliances. Electrical appliances, if they are not intrinsically safe or they are not present in flame proof enclosure, the spark that may come out outside the machine, and this spark is a prime source of ignition or explosion of methane that is present in the surrounding atmosphere. And if methane is present in proper concentration, then explosion can be taken place. Then friction. And intensive frictional spark at a high temperature is capable of causing an explosion. This friction can be caused due to movement of rope over pulleys, movement of belt over idlers, and rubbing against steel or timber supports, and continuous rubbing causes heating, and finally a spark gets released, which causes ignition of methane or finally results in explosion. Fire. Fire in coal mines or spontaneous combustion of coal can cause ignition of fire damp that may lead to explosion. Fire, either due to external cause or due to auto oxidation, spontaneous combustion, is a prime source of heat for fire damp, and once fire has broken out, it gives heat and high temperature for fire damp and can cause to explosion. And sometimes foolishness of miners means some miners means those workers working in underground mines engaged in smoking, welding without protection, making fire or opening of flame safety lamp may result in ignition or explosion of fire damp. This is some unwanted activity caused by the workers resulting fire damp explosion. Now come to ignition temperature. Ignition temperature is the minimum temperature of methane at which the methane air mixture burns in the air to give a flame. The ignition temperature of fire damp air mixture is 650 to 750 degrees centigrade. This means for fire damp explosion, the source of temperature should be between 650 to 750 degrees centigrade. It is not a definite temperature, but depends upon the nature of source of ignition, flame or spark, shape and size of surroundings, pressure, oxygen concentration, presence of other gases. If presence of inflammable gases is, then the ignition temperature becomes low. If there is presence of non-combustible matter, the ignition temperature becomes high. Quad diagram. It is a diagram presented by Quad and Jones in 1952. Is fast and easy way to determine the explosibility of mixture and air and combustible gases like methane. The diagram shows the limits of explosibility with different percentage of fire damp and oxygen. It has significance during sealing of fire in gassy mine and when reopening a sealed off area. This diagram explains the probability of fire damp air mixture in a panel or district of an underground coal mines. This diagram is very important for the prediction of fire damp explosion and a study of the happening or possibility of occurrence of fire damp explosion in underground coal mines. This is the quad diagram that is presented here. We can see a triangle in middle. It is of orange color. This is the most explosive condition or most explosive concentration for the methane air mixture. This triangle shows the methane air mixture can cause explosion at maximum violence. The nose of the triangle is called nose limit. This is the concentration of methane which produces most violent condition. We see there are 4 areas. The left one may become explosive, that is, the air is sufficient to explode a methane. In bottom one, not capable of forming explosive mixture with air, because this area there is insufficient air or oxygen as well as insufficient methane. So, the insufficiency of methane as well as air gives incapability to form methane air explosive mixture, but the right one is capable of forming explosive mixture if diluted with air. In this area, the methane content is sufficient, and if air concentration is sufficient, then the mixture can form an explosion. Qua diagram describes all mixture lying within the triangular area are in themselves explosive. All mixture lying to the right of PYZ contain too much fire damp to explode, but they will form explosive mixture when mixed with right amount of air. All mixtures lying to the left of PYX are neither explosive nor capable of forming explosive mixture with air. Lower limit of explosibility remains almost constant at about 5.4% of all percentage of oxygen down to about 12.5%. It means if the oxygen percentage should not be less than 12.5% to form explosive mixture. Similarly, the methane percentage should not be less than 5.4% to form explosive mixture. If methane percentage is less than 5.4%, then it is not sufficient to form methane air mixture. If oxygen percentage is less than 12.5%, then the explosive mixture cannot be formed because of the less concentration of oxygen. The higher limit of explosivity gradually decreases from 14.8% to about 6% with decreasing oxygen percentage. No percentage of fire damp is explosive when the oxygen percentage is 12 or less. A fire damp air mixture may become explosive when diluted with an appropriate quantity of air, which brings the new mixture within the limits of the triangle X, Y, Z. So, the triangle X, Y, Z is the main contents that depicts the real concentration of methane air mixture that has capability to explode or cause an explosion in underground coal mines. Prevention of fire damp explosion. How can we prevent from fire damp explosion? There is no practical measures exist for arresting fire damp explosion in coal mines. Only protective measure against this hazard can be adopted. The various measures against fire damp explosion hazard in mines can be divided into the following three groups. Measures against accumulation of dangerous fire damp mixture in mine workings. Measures against ignition of flammable fire damp mixture, control of fire damp explosion. If we come to first point, it means first of all we have to prevent the accumulation of fire damp in any part of the mine working, because if there is a sufficient accumulation of fire damp, then it is possible to form explosive mixture and cause fire damp explosion. Measures against accumulation of dangerous fire damp mixture in this can be achieved. How you can achieve? By providing adequate ventilation to dilute the fire damp below limit and carry it away to surface. The mine should be mechanically ventilated, because naturally ventilated mines does not provide sufficient velocity of air which can dilute methane. So, we use fan of sufficient capacity which deliver the air at a prescribed speed that breaks any layer formed near the roof or can dilute the higher concentration of methane to maximum allowable concentration. The sampling of mine air for methane should be carried frequently of several points in the mine. It is very important task that the percentage or concentration of methane can be known at various places inside underground coal mines, so that any higher accumulation or any concentration of methane higher than prescribed maximum allowable concentration can be detected and proper measures can be taken. If possible, an automatic alarm or signal should be arranged against accumulation of methane above threshold limit value. It is an important and automatic and reliable system, because it warns time to time workers that the accumulation of methane has reached the dangerous level. Depillaring seams top downwards to decrease methane content in lower seams, keeping air leakage as minimum as possible. Special examinations of layering of methane. We calculate layering number, and on the basis of layering number we improve ventilation or take proper action. Measures against ignition of flammable fire damp mixture. If there is sufficient amount of fire damp explosion has taken place, then we should take such type of action that the ignition of fire damp cannot be taken place. All persons should be prohibited from carrying a smoking article, matches or other spark or flame making devices. They should be checked before entering the mines by a competent authority, and if present they should be prohibited to enter the mines. All coal mines should be treated as safety map mines, because in working we have to be safe, otherwise we can't work. So, whole mines should be given priority towards safety. Only approved type of flame and electrical safety lamps should be used. The flame safety lamp or electrical appliances should not provide any type of flame or spark that may ignite the methane air mixture. Flame safety lamp should be properly assembled and carefully brought in mine and always kept in vertical position. Only certified flame proof and intrinsically safe apparatus should be used in coal mines. The apparatus should be properly installed, protected, operated and maintained. Otherwise, it gives flame or explosion takes place outside the lamp, and the whole mine may be affected due to flame safety lamp and fire damp explosion. Control of fire damp emission. Seams with high methane content at great depth should be intensively worked by high production method. Methane drainage techniques to be applied when it is not possible to control methane concentration by general ventilation. If the rate of methane emission is sufficiently high, then methane drainage system should be properly applied to drain out methane, so that it can be used as a fuel and the mines can be kept safe against fire damp explosion, coal dust explosion. Coal dust or any industrial dust explosion is a sudden combustion process of great intensity characterized by mechanical destructive effects through pressure and heat. For an ignition to take place, the combustible dust must be present in the form of a thick cloud having a definite mixing ratio with oxygen and a source of ignition or sufficient intensity in the form of flame must be present to initiate a combustion wave. It means a coal dust explosion can only be taken place if there is the availability of coal dust and ability to mix with air to form cloud and there is a sufficient source of ignition. Coal dust suspended in air is explosive. Coal dust has far more surface area per unit weight than chunks of coal or fragments of coal and is more susceptibility towards spontaneous combustion. As a result, a nearly empty coal store is a greater explosion risk than a full one. The worst mining accident in history has been caused by coal dust explosion. Such accidents were usually initiated by fired up explosion, the shock wave of which raised dust from the floor of the mine gallery to make an explosive mixture. Mechanism. How can it take place? The coal dust explosion is dependent on 5 parameters, namely coal dust, air, ignition source, confinement and dispersion of coal dust. These 5 factors constitute the explosion pentagon. The figure also depicts the further bifurcation of 5 parameters which influence the explosion pentagon. These 5 factors indicate the explosion and the observance of any one of absence of any of them rules out the likelihood of coal dust explosion. मतलब any one if not present then the coal dust explosion cannot happen. Once the explosion has occurred, it propagates throughout the mines under suitable conditions. The mechanism of propagation of methane dust is a chain reaction and combined effect. The shock wave licks the flame front. The shock wave provides energy to the dust particles, causing them to disperse. The logging flame ignites the dispersed coal dust and then process goes on until it is devoid of suitable conditions. So, it is a chain reaction that causes heat and energy and violence. This is the explosion pentagon and you can see explosive explosion how these 5 parameters jointly gives rise to the occurrence of coal dust explosion. Absence of any one parameters leads to the inability of coal dust to explode in underground coal mines. This is the final explosion pentagon. You can see the 5 parameters: oxidant, ignition source, dispersion of dust, confinement of dust and combustible dust. This is our explosion pentagon. Now comes to causes of coal dust explosion. The various causes of direct ignition of dust cloud can be classified as under naked flame, friction, electric spark and finally fire dome explosion. Naked flame. A naked flame is the easiest means of igniting a dust cloud as the source of heat is of considerable size and of large part of the dust clouds can be heated. The naked flame comes from broken glass, broken flame safety lamp, a spark, blown out shot during blasting, etc. And again comes to friction. Hot surfaces as a result of mechanical friction such as overheated bearings may ignite surrounding explosive dusty atmosphere. Again friction during rope, fast movement of belt and rubbing of belt against steel prop or timber prop inside the underground mines may also cause heating and finally ignition of coal dust, which leads to coal dust explosion. Electric sparks. Electric sparks from short circuiting and arcing of electrical equipment or overheated trolley wires may ignite an explosive dust air mixture. Sparks of higher voltage and amperage are necessary than in case of flammable fire damp mixture. Static electric sparks from batteries can also ignite explosive dust air mixture. Fine particles of dust may readily become electrified by friction with air or ducting through which they pass. As the electric charges on a body resides on the surface, a dust cloud has a very large capacity. Under suitable condition, a discharge of sudden recombination of separated positive and negative charges can occur, which can act as source of ignition. With increasing humidity, the electric potential however falls, but a spark can occur and which leads to ignition of dust air mixture. A fire damp explosion is the commonest source of ignition of a coal dust explosion. Whenever fire damp explosion occurs, it gives a prime source of heat and that causes ignition of coal dust if it is present in sufficient amount. Besides posing the danger of such direct ignition, a fire damp explosion may raise the deposited dust from the mine floor, sides and roof into mine air very quickly before its flame has ceased and then propagate as a coal dust explosion. A very small gas explosion initiated by accidental ignition of a small quantity of flammable fire damp mixture approximately 0.4 meter cube volume may thus bring about a much bigger coal dust explosion. So, for the occurrence of coal dust explosion, fire damp explosion is a major contributing factor. Control of coal dust explosion. How can we control a coal dust to form explosive mixture and prevention against their explosion? It is well known that it is much easier to prevent a coal dust explosion being initiated than being suppressed. The measures for preventing and suppressing, that is control of coal dust explosion, can be divided into the following three groups. Measures which prevent or reduce formation and dissemination of coal dust underground, measures against ignition of coal dust accumulation and measures against explosion progression. So, there are three groups that can be followed. First, measures which prevent or reduce formation and dissemination of coal dust underground. On long wall faces, water infusion of coal face to reduce respirable dust at low or high water pressure, where the seam and adjacent strata allow. The different methods of infusion of coal in situ before it is mined. Wet winning of coal using wet pneumatic picks were used, with machine cutting by means of coal cutters using sharp picks of suitable types selecting optimal cutting and travelling speeds of the machine using gummer and wet cutting, so that the dust formation can be reduced and can be wetted. When blasting in coal, use of a steaming cartridge or ampoules of calcium chloride powder containing 80–85% of calcium chloride, wetting through coal pile before it is manually or mechanically loaded, using such type of conveyor which the dust production is minimum, preventing spillage and degradation of coal during transport through haulage roads. Measures against ignition of dust accumulation. These measures comprise measures against ignition of flammable fire damp mixtures, neutralization of dust at working coal face within a radius of 10 to 20 meter before shot firing by means of water or inert dust, neutralization of dust in roadway by means of water, inert stone dust and hygroscopic salt. Measures against explosion propagation. These includes generalized wetting of coal dust, that is a sprinkling of water or a spraying of water throughout the mines. Generalized stone dusting. The incombustible stone dust should be sprayed throughout the mines. A stone dust barrier. Use of a stone dust barrier, explosion stopping, salt zone, water barrier, trigger barrier. A stone dust barrier, it is a device which uses the dynamic pressure of explosion to release and disperse a mass of stone dust in the form of thick cloud into the path of an oncoming explosion flame, thereby smoothing the flame. Stone dust barriers are installed in strategic areas, the mine as roadway leading from shafts or their pit bottoms in all level and inclined roadway including gate roads and development headings and near roadway junctions. This is the polished type of stone dust barrier. You can see the visual, the figure, the upper part has planks which receives dust, stone dust, and after explosion it breaks and gets spread over the coal dust, and that is why the propagation of explosion gets stopped. A stone dust barrier must carry not less than 400 kg stone dust per square meter of average cross section of the roadway in which it is installed. At least a quarter of the total dust loading of any barrier must be distributed on light shelves of the barrier at either end. The heavy shelf must carry at least a quarter of load dust loading. The stone dust barrier of three types, the light, intermediate and heavy type. Two types of polished shelves are used. The light shelf, the width of which should not exceed 35 centimeter, has a dust loading not more than 29.8 kg per meter and shelf length, while the heavy shelf, the width of which should not be less than 35 centimeter and not more than 50 centimeter, is loaded with not more than 59.6 kg per meter or less than 29.8 kg per meter. The light barrier carries a total loading of at least 107.4 kg per square meter of average roadway cross section and comprises all shelves of the light type. The intermediate barrier carries a dust loading of 19.53 kg per square meter roadway cross section and a comprise of more than one third of the shelves of the heavy type. The heavy barrier of dust loading of at least 390.6 kg per square meter of average roadway cross section and comprising not less than one third of the shelves of the light type. And these are the references which is used to deliver the presentation. Thank you.